Hi, this is Dr. Saravanan A, Associate Professor, Department of Mechanical Engineering in Sri Muthukumaran Institute of Technology, Mangadi, Chennai. Today we are going to discuss about the lecture notes in Design of Machine Elements. Subject code is ME3591. This is Regulation 2021. Let's start with the notes. Its core objective is, first point, to learn the various steps involved in the design process. Next point, to learn the design shaft and couplings for various applications. Third point, to learn the design and temporary and permanent joints. Fourth point, to learn designing helical, leaf springs, flywheel, cutting rods and crankshaft for the various applications. And the last point, to learn designing and selection sliding and rolling contact bearings, seals and gaskets. Here you can use the PhD data book for design calculations. Next, syllabus. In the first unit is fundamental of concepts in design. In fundamental concepts in design, the first point is introduction to design process. Next, factors influencing the machine design, selection of materials based on mechanical properties. Next, preferred numbers. That preferred numbers subdivision into direct, bending and torsional loading. Next, modes of failure and factor of safety. Next, combined loads, principal stresses, eccentric loading and curved beams, crane hook and C-frame, theories of failure, design based on strength and stiffness, stress concentration, fluctuating stresses, endurance limit, design for finite and infinite life under variable loading, exposed to standards. Next, introduction to the first topic is introduction to the design process. First, in the initial stage, the subject machine design is creation of new and better machines in the improving existing one, already existing in some of the machine components available in the market and existing in the world. That should be updated in the point of enhance in performance and application wise. Next, the process of design is long time consuming one. From the study of existing ideas, new idea has to be conceived. Next point, in a design of machine component, it is necessary to have a good knowledge of many subjects such as mathematics, engineering mechanics, science of materials, engineering drawing and theory of machines, etc. Next, the concepts of engineering design. Engineering design is the process of applying various scientific principles and techniques for purpose of identifying in a detail a product or a process or a system to its realization. In simple words, design is a formulation of plan for execution towards satisfying a needs. Ultimately, machine design is defined as a fixed dimension for the machine component. So we have to find the dimension for the every component with the particular applications. The various design process. First point, need or aim, recognition of need. Next, synthesis, that is called mechanisms. Third point, analysis of forces. And fourth point, material selection. Fifth point, design of elements. Sixth point, modification. Seventh point, detailed drawing. Eighth point, production. In various design process continued. First point, recognition of need. What is meant by recognition of need? It is identifying the customer needs through the market research. If any customer need some modification or new techniques or new methods or new products they are expecting we have to identify through the market research, then finally go for the recognition of need. Next point, definition of the problem. In the definition of problem, preparation of complete list of technical specifications with the current existing one. The technical specifications is come with brainstorm discussion among the design people. Next, synthesize. Synthesize is nothing but it's a collection of new ideas and relative data for the modifying or existing the available in the market. This synthesis is very very important because the collection of or pinning the data is the key matter for the new existing new product or new design. Analysis. This analysis can be converted into two types. First one is the force acting on the component are determined. Next one is the geometry for the component dimensions determined. Next one is material selection. The material for the component is selection based on the application, environment condition and cost and surface color and etc. Next, evaluation. the possible success of proposal should be verified from the technical and economical standpoints, because if you go for the cost is high, the product selling market in the at obviously very low, because the cost should be a valuable point. Next, detailed design. The design comes with it shows axle sizing and dimension of the all individual components of the part. If go for the any component, it has numerous number of components are there. That component should be a exact size, and it should be a tolerable one, it should be a correct material one, and etc. comes into the single pictures called detailed design. Next, prototype and testing. It is led to some necessary modification, some for the particular application. If go for the prototype for the particular component, we can comes into the conclude whether the product is suitable or not, and the dimension is completely suitable or not. Next, production. After finishing all this process, come to the production. In the production process, the actual component can be manufactured at the shop floor. Types of machine design. Next, in the types of machine design, there are three different types of machine designs are there. First one is adaptive design, next development design, next one new design. Adaptive design, the designer makes only some alternatives and modification in the existing design of a product. If there is no modification and alteration, so they will go for the some material selection. Based on the material, they will come for the conclude whether the material is suitable for not, or if you want to choose for some other material. Next, development design. The modified existing design into new idea by adopting new material or different method for the techniques of manufacture. If go for the new materials, nowadays new materials come to the market like composite material, metal magnetic composite, natural fiber composite, etc. Carbon reinforced composite also available in the market, but its cost is too high. But in this type of material is carrying a high amount of load with some good environmental condition, especially for the temperature and cold applications. This all comes under the development design. Next, new design. In this type of design needs lots of research, technical ability, and creative thinking, because new design is not only the copy maker of the old design. It may be entirely different from the old one. So the new design needs a lot of research research backup, and technical knowledge and technical ability, and especially for the creative thinking. Next point, factors influencing in the machine design. First point, safety. Next point, reliability. Third point, quality. Fourth point, productivity. And fifth one is cost. And sixth one is ecological consideration. And next point, availability of man, machine, and materials. And last point, working environment and energy conservation. It comes to the first point, safety. That component should be a safest one, and next one is the component should be a reliable one for the all material condition, all environmental condition. Next one is third one is quality. The quality is nothing but that product should be valid and workable for the given working time. Next, productivity. Productivity is the ratio between the production divided by input. The production is nothing but whatever the component getting from the industry is called production. Input is nothing but man input, machine input, etc. The ratio between the productivity, the ratio between the output by the input, that is called productivity. Next, cost. Cost is the major criteria for the every component or the product. Next, ecological consideration. Whether it is that product should be suitable for the particular environment. Next, availability of man, machine, and materials. If the component is suitable for particular applications, that should be a manufacturer for the particular place. That place should be, man should be available, machine should be available, that particular material should be available. Next, working environment and energy conservation. Working environment should be suitable for the particular machine component or component manufacturing. Next, material selection. Materials can be divided into many types of materials, but in our syllabus only two types of material only we consider. First one is metal and non-metals. Metals can be classified into two types. First one is ferrous and non-ferrous. In ferrous, the example in ferrous, which contains iron as a major constituent, is called ferrous. Material does not contain iron, is called non-ferrous. The example for ferrous is steel, cast iron, etc. Non-ferrous material example is copper, aluminium, etc. Bronze, magnesium, etc. And next category is non-metal. Non-metal is example for non-metal is ceramic material and organic material. In ceramic material that combined with oxides, carbides and nitrates and various metals, exert glass, brick, concrete, cement, etc. In organic materials, polymeric materials composed with carbon compounds, example paper, fuel, rubber and etc. These are the considered non-metal category. Next, factors should be considered for the material selection. The first factor should be availability. Next one is cost. Third one is physical properties. Fourth one is mechanical properties. And fifth one is manufacturing process. Next, physical properties. The physical properties should be comes for the aesthetics of the particular product. Example, color, shape, size and density. If the light density material will give the very good automobile application, and moreover electrical conductivity and thermal conductivity, because based on the material application the electrical conductivity and thermal conductivity is very important. If the material applicable for some automobile component, the thermal conductivity is very important. If the materials applicable for some electrical application, the electrical conductivity is very important. Next, material selection based on the mechanical properties. The materials property, the mechanical property for the material is strength and stiffness and elasticity and plasticity and ductility and brittleness and malleability and roughness and machinability and resilience and creep and fatigue, then hardness. The definition for strength is ability to resist external forces. The concept for stiffness is ability to resist deformation under stresses. Elasticity, this is the property to regain its original shape when applying the load. Plasticity, property which retains in the deformation produced by under load. Ductility, this is a property of material to be drawn into a wire from the wire form which applying the external loads. Brittleness, property of material which is breaking under applying the load. This malleability, the property of material should be a rolled or plate or deformed shape for the applying load. Toughness, the property of resisting fracture is called toughness. Machinability, property of material to be a cut or machined. Then resilience, the property of material should be absorb energy. If taking that spring or damping materials, it should be a absorbed energy. That property is very important. Creep, material undergoes slow and permanent deformation under the subject of constant stress load. Then fatigue, the failure of material due to cyclic loading, that is repeated loading. Then hardness, hardness is the deformation or indentation or scratching is the resistant property is called hardness. Next, the properties of material. Main property can be converted into two types. First one is stress and strain. First, let me explain the stress. Stress is nothing but the internal resistance of force per unit area is called stress. If you take that material, if you apply the external load, the material will give some resistance force. This can be calculated by using this formula. That is, stress is equal to P by A. P is nothing but load applied on the body. Area is nothing but cross-section area of the particular body. That unit for stress is nothing but Newton per meter square. Then strain, the rate of change of deformation or it is the ratio of change in dimension into original dimensions of the body is called strain. This formula comes into the strain is equal to change in dimension divided by original dimension. Types of stress and strain. Let me come to first types of stresses. First one is tensile stress. It is the force applied per unit area of the material when it is subject to stretch or pulled force. In simple terms, it measures how much pulling force the material can be withstand. It is defined by a formula. Tensile stress is equal to tensile force divided by cross-sectional area. In SI units, it is a Pascal or Newton per square meter or meter square. Next, compressive stress. It is a force applied per unit area of material when it is being compressed or pushed. In simple terms, it measures how much squeaking force of material can withstand by applying the force. Definition: the compressive stress is equal to compressive force divided by cross-sectional area. The unit for the compressive stress is equal to Pascal, that is Newton per meter square. Then third one is Shear stress is the force applied per unit area of a material when force acting parallel to its surface, causing one part of material to slide over to another. In simple terms, it measures how much sliding force of material can withstand. Definition: shear stress is equal to shear force divided by area. This is also unit is Pascal, that is Newton per meter square. Thank you. That's all.